Hey guys, just thought I'd make a quick video on the AP answers. Okay, AP number 4, alright, on these 4 chapters. Okay, first question, the MCQ question, moment of a force. I think most of you probably would choose either B or C. Okay, correct answer is C because moment is product of force times perpendicular distance, right? Well, I believe most common answer B, but B is not the moment of a force. Take note, B is the principle of moments. For some of clockwise goes some of anti-clockwise moment about pivot, right? Okay, question 2. Okay, designer wish to make a lamp more stable, so something to be more stable, two criteria. Gotta have a lower center of gravity plus heavier base. So this is the one. So lower center of gravity plus the width of the base. So gotta have a larger base area also. Okay. So that's all for A. Answer question 3. Okay, what are the changes involved in classroom projector? So classroom projector is always starts with electrical energy, ends with light, right? So when light, after we see light, which is what you're seeing on the screen right now, okay, one of the byproducts is also mainly thermal energy. Do you hear a lot of sound energy coming out from the projector? I don't think so, right? So even if there is, this is minimal, okay? Thermal will be the main one, okay? Because it's probably quite hot if you were to put your hands near either the light or the projector. Okay, so question 4. Okay, a student carries out the following action. In which scenario does he do most work? So you gotta know, work is actually the formula is force times distance. Okay, so for force times distance, for question A, carrying a pile of books is upwards, walking forward. So these the two are perpendicular, cannot. So the force and distance need to be parallel, in which closing a door, you push and the door moves, the drawer moves in the same direction of the force. So this does the most work. For C and D, there's no distance move. So the work done formula based on this, if this is 0, the work done is actually 0. Okay, just recap for A again. A is 0 also because these two, force and distance, needs to be perpendicular. Okay. All right. Question 5. The kinetic model of matter states atoms and molecules move in continuous random motion. Okay, this is just the definition. Okay, 6a, define mass. Mass basically amount of substance in an object. SI unit, kilograms. Calculate the weight of the object on Earth. Weight is mg, W equals mg. So you got m here, you got g here. Just multiply 600 newtons. This was an error here, right? So weight equals 600 newtons. Describe one difference between mass and weight. Okay, any one of, I'm not sure you can see this, but any one of these differences. Okay, this is pretty straightforward. Okay, question 7. The diagram below shows antique Chinese weighing scale. So over here, basically this pivot, this string here can move left and right. So state principle of moments, sum of anti-clockwise moment equals sum of clockwise moment. You gotta have this about the same pivot. Okay, so over here, the next question for question B, they say if I increase the mass of herbs on the tray, what is the direction that the pivot should be shifted, left or right? So you can see here, just like what I said, this is a movable string. You can actually move it left, right, left, right. Okay, okay, so to move it left or right, if I have more mass here, that means the anti-clockwise moment is higher. You cannot change this fixed mass, so you have to move this left. Okay, so how do you actually explain it? Okay, two ways to explain. So one mark for this. Okay, so two ways to explain: to increase the clockwise moment of a fixed mass, that's for second mark, so that you can balance the anti-clockwise moment of the additional herb. So basically you want to increase one moment to balance the other moment, or if you move left, effectively you are decreasing the anti-clockwise moment just to balance the clockwise moment of the fixed mass. So basically, if you move this here, you are either decreasing this moment so you can balance this here, or you can increase this moment because you move left, right? That's longer distance. Increase this moment to balance the additional weight, the additional moment caused by the additional herbs here. Okay, so second mark for to balance the anti-clockwise moment. Okay. Question 8. You can see over here, given mass, given height, given G, gravitational field strength, calculate the GPE of the plate, just use mgh. So mg times h. H is actually 40 meters here, right? So 40 meters, you just multiply it times 40 equals to 400 joules. That's it. Okay, determine the speed of the plate. Okay, using conservation of energy, gain in kinetic energy equals to loss in GPE. We covered this in class. Okay, basically just before it hits the ground, this is the half mv square. This is actually the KE. Okay, loss in GPE. So this is GPE. So based on this formula, you can cancel out mass, and V just bring 2 over the other side and then square root the whole thing. So you go square root 2 GH. That's it. 28.3 meters per second. Okay, so you realize I don't really need M over here, right? Okay, question 9. Work done formula is just force times distance. You gotta make sure this force is the distance isn't moving in the same direction as the force. So okay, if it is, good to go. You're good to go. All right. So force 200 times 0.5, that equals to 100 joules. So if I can fire 90 bullets per minute, okay. So that is, you gotta remember, times 90 divided by 60 seconds. So that is the final answer for power is 150 watts. Okay. Okay, basically these two questions here, you just need to know this. Make sure you know this. Work done formula equals force times parallel distance, and power equals to work done over time. That's it. Okay, question 10. All right, an alloy is made of 2 or more metals. Okay, so I got one, what's this? One volume, one density for alloy 1, and volume of alloy 2 or metal 2 plus density of metal 2, right? So you got volume density, volume density. So mass is simply density times volume. That's it. Okay. So let me just move this up here. Mass density times volume. That's why I got 5 times 4 plus 6 times 8. Okay. So this is a total mass, just 68 grams. That's it. Okay, so when the alloy is produced, it's in a liquid state. The rest is using kinetic model of matter. Explain why the liquid has fixed volume, not a fixed shape. So you got to talk about strong intermolecular forces holding them together, so it's incompressible. That's why it has fixed volume. That's for the first mark. Second mark, no fixed shape, right? So no fixed shape is because, so you can ask yourself, when do we see something in fixed shape? Only in solids. So why do solids have fixed shape? Okay, because of the very strong intermolecular forces. So you can't really use, you got to word this correctly, because you can't say that forces are strong. Strong, so it's incompressible, but you got to say not as strong. You can't really use the word weak, because if you use the word weak, you're actually implying it's something like a gas, because the forces are still relatively pretty strong in liquids, just that they are not as strong. So this is the key word, right? So it does not take up the shape of the container. That's why no fixed shape. Okay? So, part 2 here, why the mass of 1 cm cube of solid alloy is slightly more than the mass of 1 cm cube of liquid alloy. You can see mass per unit volume is density, right? So density equals to, got to use this formula, density equals to mass over volume. So how you do it is basically, first you compare solids and liquids. Okay, so solid and liquid just to compare. So spacing between solids is smaller than liquid. That's why it results in more particles per unit volume in the solid. That's why there is a higher density than liquid. Okay, let me just add this here. Per unit volume in solids, resulting in higher density than liquid. Solids have a higher density than liquids. Okay? All right. Question C. Okay, so once in the solid state, so just take note, this is only in the solid state. So if it cools down, what are the changes? So you gotta say, you cannot say it starts to vibrate, because if you say it starts to vibrate, you're implying that it didn't vibrate in the first place. So that's not really true, right? So you gotta say vibrates slower as it cools down. Okay, what about energy of the solid alloy particles using conservation of energy? So conservation of energy, I know that my Ke is lost, right? Because it vibrates slower, right? So vibrates slower, gonna give you the impression of speed. So it goes slower. So that's why my Ke is reduced. So if I reduce my Ke, loss in Ke gotta be gained somewhere, right? So where does the Ke go? Increase thermal energy of surrounding. All right, that's it for this paper. Okay, hope you, well, it doesn't really matter how you did. Most important, never give up. I'll catch you in the next.